Hello everyone, welcome back to another exciting lecture of process modeling and simulation. And we are covering module number 2 these days, and we have so far simulated all these equipment except compressors. So our this is the last activity related to this module, which is related to the simulation of compressor. And again, one simulation will be simple based on the discharge pressure, and other activity just like the pump is related with the performance curve. So let's quickly go to the cases and see what are the simulation requirements and how we can achieve our required results. So this activity again is linked with CLO number 1 and CLO number 2. The objectives are the same as that of the pump, that knowing how to change the pressure of the vapor stream. In that case, in pump it was a liquid stream, in compressor it is a vapor stream, and recognize the way of using compressor in Aspen Plus. So the problem description is that calculate the duty of the compressor which is required to increase the pressure 10 times from the feed pressure, that the ratio of outlet pressure to inlet pressure should be 10. This exactly means the 10 times, or multiply the inlet pressure by 10 to get the outlet pressure, the discharge pressure. The flow rate is 2000 kg per hour of feed mixture, 58% benzene and toluene, which is supplied at 250 degrees centigrade and 1.5 bar. So the feed pressure is 1.5 bar, and you have to increase the pressure 10 times from the feed pressure. It means 10 multiplied by 1.5, so it will be 15 bar at the outlet, or you can specify pressure ratio as 10. So there are two ways of doing this activity, that you can either specify discharge pressure by multiplying 1.5 by 10, or you can simply specify the pressure ratio as 10. तो देखिए ना प्रेशर रेशियो क्या है, आउटलेट प्रेशर टू इनलेट प्रेशर, वो कितना है आपके पास 10. दूसरा केस क्या आपके पास, कि आप डिस्चार्ज प्रेशर को स्पेसिफाई कर दो, वो कितना होगा 10 टाइम्स है, तो 10 मल्टीप्लाइड बाय 1.5, तो कितना बना 15 बार. एंड अगेन degree of freedom is 1, that you have to specify discharge pressure, either pressure increase, ratio, power required, or performance curve. So these are the feed conditions. The compressor type is isentropic. The pressure ratio should be 10, or you can specify discharge pressure. It's up to you. And again, since the pressure ratio is related with the degree of freedom, this efficiency in compressor case is also not related with the degree of freedom. It's an optional step which you have to do if the efficiency is given. Otherwise, there is no need of doing it. So it's 75%. This efficiency is not related with degree of freedom. So let's quickly go to Aspen Plus and solve it. I don't think there is need to review the procedure because it will be the same as that of the pump. So just like the previous activity, benzene toluene is added over here, and similarly SR and steam and base is added. Similarly, click next, click run. After results are available, click on simulation environment and go to pressure changer, and in pressure changer select COMPR, compressor dash turbine model. Means the same model can be used to simulate a turbine in Aspen Plus. As you can see, this is a compressor model icon 2, this is icon 3 which shows the turbine model. So add compressor, name it as COMP, compress, and then expand it a bit, and then do the required connections of inlet, or you can name it as feed and product, just like you have done it in pump as well. Now define the feed. The feed is at 250 degrees centigrade, 1.5 bar, with a mass flow rate of 2000 kg per hour. Mass fraction of benzene and toluene is 0.5 and zero point 0.5. After that, click next, and you come to this compressor environment. In specifications, you can either select compressor or turbine. Turbine or expander, it is opposite of compressor, just like heater cooler, if you remember the previous exercise. So in type, you have to select the isentropic, and you can either specify the discharge pressure or pressure ratio. In this case, I will specify pressure ratio. You can also do it with discharge pressure, there will be no difference. So it's 10, and you see the run button is active. However, since you have been asked to specify the efficiency in this case as well, which is 75%, as I have told you that this efficiency is not linked with degree of freedom, because if it was linked with degree of freedom, then this run button would not have been active. 0.75, and after that click run, Once after running, go to main flow sheet and results are available. You can see by clicking on results that compressor model is isentropic, phase calculation vapor phase, obviously it's related to vapor. The required power is 88.8876, approximately 89 kilowatt. The outlet pressure is 15 bar and outlet temperature, obviously temperature increases in it, which is 338.821. And isentropic outlet temperature is 320.373 degrees centigrade. So that's how you do the simulation of compressor when you are given the value related to the pressure. That either you are given a discharge pressure or you are given the pressure ratio. Similarly, if I take it to discharge pressure and do it as 15 and again I run it, then you see there will be no change in the results. The results will be same because the outlet pressure is same. So that's one part of this activity. Then other part is related with the performance curve. The same case as we have discussed in the case of simulation of pump. So let's quickly go to the slides, read the procedure, and then we will come back in it. And just like the pump, I will say that the mixture to be used is pentane hexane mixture. So this is second activity. The objectives are same, the CLOs are again same. Calculate the duty. In the previous case, we had calculated the duty, but in this case, we have to calculate discharge pressure of the compressor or the discharge pressure of the outlet pressure of the stream at the exit of the compressor if we have the compressor curve data. The operating shaft speed of the compressor is 7,000 RPM, and we have been given that a mixture having flow rate of 30,000 kg per hour, 50 weight% pentane and 50 weight% hexane is supplied at 200 degrees centigrade and 1 bar. The degree of freedom again is 1. The Peng-Robinson property package will be used. These are the feed conditions. The compressor type to be used in this case is polytropic using ASME method. And this is the compressor curve data in which reference speed is given as 6177 RPM, flow rate in actual cubic meter per hour, head in meter, efficiency in percentage. So just like you have added pentane hexane, Peng-Robinson selected compressor, specified the feed conditions, and in compressor you will specify polytropic using ASME method, because once you are dealing with the curve data, then you have to change the type to polytropic in this case and use performance curves to determine the discharge conditions. After that, it's tabular data, since like that. And now it's not at operating speed. If I take you back, then it is at reference speed, which is 6177 RPM. If here it is mentioned as operating speed, then we have selected single curve at operating speed. And similarly, performance is head, flow rate is volumetric flow rate because it's cubic meter per hour, head is in meter, and efficiency in percentage. Optional curve is efficiency, actual flow is volumetric flow, performance is head. After that, you go to curve data and you had specify head versus flow combination. Means you will specify head versus flow combination over here, and then in the next part, which is the efficiencies part, you will specify efficiency versus flow parameter over here, and then in operating speed you will specify the operating shaft speed and the reference shaft speed, and then you will run it and simulation will converge. So let's quickly go back to Aspen Plus and solve it. And I have already added the data, the performance curve data in Excel, so I will simply copy paste. So I have already done the pre-required steps, added the components, property package, running it, and then I have done the connection. So I will simply go to the inlet and I will specify the conditions: 200 degrees centigrade, 1 bar, 30,000 kg per hour, mass fraction as 0.5 for pentane and 0.5 for hexane. Click next, and in compressor type select it as polytropic using polytropic centrifugal pump using ASME method. This could be isentropic, but we are taking the polytropic efficiency, and then use performance curve. And after that, going to this performance curve, this is the tabular data. Performance is head, actual flow rate, either mass or volume, so it's volumetric flow rate. Optional curve is efficiency curve. If you click on power, then you see this power is now active, but it is not related to the power, it is related to the efficiency, which is the given data. And number of curves, single curve at reference speed. And once you activate, then you see curve data is now active. And in head, if you see, the units you have to give is meter, and in flow unit it should be cubic meter per hour, cum. Here cubic meter, meter cube, is represented by cum per hour. Just like the pump, it was gallons per minute, so it's not written as gpm, it's gal per minute, as we have discussed in the case of pump. Now the first curve which you required is related with head and flow, so I will take you to the excel, and this value is related with head and this is with the flow. What you do, you will simply copy it and you will paste it here, and you see all the parameters are now available. I have done it in 2 steps, मैंने इसको 2 steps में किया क्योंकि सारी वैल्यूज एक टाइम पे कॉपी नहीं होती, तो मैंने पहले 10 वैल्यूज को एंटर कर दिया और उसके बाद फिर बाकी 3 वैल्यूज को मैंने बाद में एंटर कर दिया. Similarly, I will add efficiencies, go to efficiencies curve, and I will define the efficiency curve over here in the same fashion, and I will quickly do it. So in the same fashion, efficiency values are added over here. मैं यहाँ पे रिपीट करता चलूँ आप लोगों के लिए कि आप डायरेक्टली यहाँ पे वैल्यूज दे सकते हैं या आप एक्सेल से कॉपी करके भी दे सकते हैं. मैंने सिर्फ टाइम बचाने के लिए कि आपको मैं ये दिखाऊं ना कि बार बार कैसे ऐड हो रही, क्योंकि हम ऑलरेडी इस चीज़ को डिस्कस कर चुके हैं कि आप पहले यहाँ पे वैल्यूज एंटर कर लें, फिर यहाँ पे वैल्यूज एंटर कर लें, या आप डायरेक्ट एक्सेल से कॉपी पेस्ट भी यहाँ पे कर सकते हो. अगर कोई मिसिंग वैल्यू रह जाती है तो उसके करस्पॉन्डिंगली उस मिसिंग वैल्यू को जो है वो इनकॉर्पोरेट कर दें. सिमिलरली यहाँ पे भी आप कर सकते हैं. एंड देन गो टू ऑपरेटिंग स्पीड, and the operating shaft speed is 7000 rpm and the reference speed is 6177 rpm. And after that, this run button has been active. Click on run the simulation. After that, results are now available. Click on compressor results and you can see that the horsepower required is 412.92 kilowatt, the indicated horsepower, brake horsepower, and the network required, the efficiency which is calculated by it. You hadn't defined the efficiency. Performance curve has calculated the efficiency value. It is 0.948 or 94.8%, and the outlet pressure is 2.55 bar, and the outlet temperature at isentropic, and in case of outlet temperature it is also given over here. Similarly, go to the stream results and you can see the results are there as well. So that's how you simulate compressor by using 2 different techniques. Number 1 was to simply specify the discharge pressure or pressure ratio, and number 2 by using the performance curve, and this activity also same as that of the pump. Obviously the procedure is different, but in pump we have specified discharge pressure first time, then we have used performance curve. Here we have also done the same. So that's how you simulate compressor in Aspen Plus. If I take you back to next exercise, then perform steam engine simulation in Aspen Plus and refrigeration cycle simulation in Aspen Plus. These are the homework tasks. And for further exercise related to heat exchanger, pump, compressor, you can follow this book and chapter number 3 and 4. Similarly, you can follow this book and chapter number 8, which is related to pump, turbine, compressor, and chapter number 10, which is related to the heat exchanger. Take one example of turbine and simulate it in Aspen Plus, and if you find any difficulty in it, we can also discuss it in our interaction session as well. And similarly, if you want further more exercise, then this book, chapter 3 and 4, these are related to the activities which we have performed in this module. So this module is now officially over, and we have simulated all the equipments which were given to us: mixer, stream splitter, flash separator, decanter, component splitter, heat exchanger, heater, cooler, pump, and compressor. So I would suggest to now change the mixture, use some other component, and simulate these equipment for better understanding. क्योंकि अभी आप लोगों ने बेंजीन, टॉल्यूइन या पेंटेन हेक्सेन मिक्सचर की, अभी आपने इससे बाहर नहीं गए, तो अब इससे बाहर जाएं, इससे बाहर जाके देखें इस मिक्सर और मिक्सचर को यूज करके देखें. मैथनॉल वाटर को यूज कर लें, एथेनॉल वाटर को यूज कर, कोई और मिक्सचर यूज करके देखें. So that's all from this module 2. Thank you so much.